Hey everybody, this is Mr. Longo, and welcome back to part 2 of solving trig equations. The only difference is these examples are going to be just a little bit harder. Not much, but it involves factoring, which is something we've been doing in this class and last year and the year before and the year before, so it really shouldn't be that big of a deal. So number 1, we're just going to jump right to it and say this is an example where you just have to factor out a greatest common factor. You have a 2 sine squared theta and a root 3 sine theta. So you can factor a sine out of both of these just by doing a greatest common factor. So if you factor out a sine theta, you are going to be left with 2 sine theta plus the square root of 3. And that's equal to 0. And just like any other equation we have ever factored before when solving, after your factor, you just set each term, sine theta, and 2 sine theta plus the square root of 3 equal to 0. Okay, and now we're just going to solve. So sine of theta is equal to 0. That part's already done. And then we have to solve this one. So we would subtract the square root of 3, giving us 2 sine theta equals a negative square root of 3. And divide both sides by 2, so sine of theta is equal to negative root 3 over 2. And now we get back to the unit circle where we go find where all of these take place. So remember, sine is our y value, so sine is equal to 0 at 0 and pi. And sine is negative in quadrants 3 and 4. So to think about that, when is sine equal to root 3 over 2? So our reference angle, root 3 over 2, is going to take place up here at pi over 3. But again, we're not using pi over 3, that's just our reference angle. So pi over 3 past pi would be 4 pi over 3, and pi over 3 away from 2 pi would be 5 pi over 3. So all 4 of those are our answers to this question. So theta is equal to pi, 4 pi over 3, 5 pi over 3, and then, of course, 0. I should have put 0 first, but oops. There we go. That is how you work when you have to factor. So really it's the same thing. You're just going to have more answers available to you. Okay, we'll do another one together, and then if you feel like you're ready to rock, go ahead and pause it. Tangent squared theta minus 1. This could be factored using difference of 2 squares. So that would give us tan theta plus 1 and tan theta minus 1 are equal to 0. Set each one equal to 0. So tan theta plus 1 equals 0. And tan theta minus 1 equals 0. So tangent is equal to a negative 1, or tangent theta. And tangent theta is equal to a positive 1. So basically this is when tangent is plus or minus 1, which means we are going to go find all 4 of those quadrants. So tangent is positive 1 in quadrants 1 and 3. Tangent is negative in quadrants 2 and 4. So we have to go back and think of that reference angle. This angle for our reference angle is pi over 4. That's when tangent is equal to 1. And we're just going to apply that to every quadrant. So pi minus pi over 4 is 3 pi over 4. Pi plus pi over 4 is going to give us 5 pi over 4. And then 2 pi minus pi over 4 is going to give us 7 pi over 4. So our answer for this problem is theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And yes, if you added 1 to both sides and took the square root, as long as you were taking the square root getting plus or minus 1, you would have gotten the exact same answer. Okay? Examples number 3 and 4 are pretty much the exact same thing that we just did. I just want your domain to be in degrees this time, so from 0 to 360. If you feel like you're ready, pause it. If not, here we go. This is an example of Batman or splitting the middle term. So to factor 2 sine squared minus 3 sine plus 1, all we're going to do is come up with 2 sine, let's see, this sounds like 2 sine theta minus 1 and sine theta minus 1. Because obviously we have to multiply to a positive one, but we need negatives, so that one's actually pretty easy to do. Set each one of those equal to 0 and then solve. So that's going to give us over here 2 sine theta is equal to 1, so sine theta is equal to 1/2. I just skipped the equal to 0 part. This one we're going to add 1, so we're going to have sine theta is equal to 1. So now go to our unit circle. Sine is equal to 1 when y is equal to 1, which takes place up here at 90 degrees. Sine is equal to a positive 1/2 in quadrants 1 and 2, and that reference angle happens to be 30 degrees, which means 180 minus 30 is going to take you to 150 degrees. So in this example, theta is equal to 30, 90, and 150. Okay? So if that helped you out, you could probably get this last guy on your own. So let's just jump to it anyway. First, you have to get this equal to 0 by adding 2 back to the left. So we're just going to change that to plus 2 equals 0. And we're just going to factor using Batman or splitting the middle term again. And that's going to end up giving us 2 cosine theta minus 1 and cosine theta minus 2. Of course, both equal to 0. That's going to give us cosine theta is equal to a 1/2 and cosine theta is equal to 2. When is cosine equal to a positive 1/2? Well, cosine is positive in quadrants 1 and 4. And our reference angle for 1/2 with cosine is 60 degrees. So 360 minus 60 is 300 in quadrant 4. And then when is cosine equal to 2? It isn't. Remember, in the unit circle, the biggest you can have for sine, cosine, and tangent is 1, because that's the radius of the unit circle. So cosine of theta is never equal to 2, so you can completely ignore that guy. And your answer is theta is equal to 60 degrees and 300 degrees. And that's it for solving harder trig equations. This is Longo and I'm out. See you, bye.